All right. Hello. This is the energy I'm bringing today, apparently. Hello. Welcome to part 32. I think that must be where the energy is coming from. The fact that we've rolled over to 6 bits. Real milestone in the history of Powers of 2. I'm writing a WebAssembly interpreter in Ruby. That's what this is. I'm doing that to have fun. I'm doing it to demystify WebAssembly a bit. And I'm doing it to just share how I do it so that you can watch me do that for some reason. Some things to remind myself. I'm doing this to have fun. So it's more important that I have fun than that I end up with a fully functional WebAssembly interpreter. I want to write correct code, even if it's not very fast code. I want to write clear code, even if it's not very clever code. I want to write pure Ruby code, no C extensions or Rust extensions or anything like that. That's going okay so far. And I'm trying to avoid any third-party dependencies. That is also going okay so far. Before I get started, I'll do a brief retrospective on what happened on the previous stream. What happened on the previous stream is that I ended up just doing a lot of work on tables one way or another. This wasn't really, I didn't really make a conscious decision that I was going to work on tables. This was just one of the many tests that looked like it might be quite close to being able to get parsing, was the element segments test. Element segments being the things that are used to populate tables. Ended up working on that basically the entire previous stream. Managed to get I think the element segment test script parsing, so that was good. And it sort of brought together, so what was interesting about it is that it sort of brought together lots of other things that I was already working on. So like that elem.drop test script sort of exercised not just element segments, but tables and imports and exports and like functions being called across modules, or like tables being accessed across modules. So sort of all of the machinery I built in previous sessions to do with like having decent runtime representations of those things and being able to have like named exports and have imports working properly and stuff all kind of coalesced. So that was good. So yeah, in a way that's sort of quite exciting. It was nice to have that feeling of, it wasn't until I reflected on it afterwards that I realized it was sort of a coalescing of lots of stuff that I'd previously worked on. So that feels good. Sort of actually relatively advanced. I mean, no, not really, but like in terms of what I was capable of executing, this is sort of one of the more advanced things because, like I said, it does involve all of this importing and exporting and mutating the tables and doing some fiddly stuff to do with module instantiation and things. Like it's a little bit more detailed and involved than what I've done previously. So I sort of feel good that that's working now. There's probably more stuff here. Like I don't think I'm currently running just the table test. But maybe I could now. I don't think I've tried that yet, so that might be something to look at this time. So I think that's one of the things I want to do is just investigate, like, what is adjacent to the stuff that I've got working now. Is there some other stuff that I could get either for free or sort of relatively low cost? So I'll take a look at that this time, I think. Also, parsing continues to be a thorn in my side. Specifically, something that I noticed last time and sort of when I was reflecting on it is that, a lot of the details of the complexity of the concrete syntax are reaching all the way through to the interpreter. And although I'm kind of dealing with them at the boundary of the interpreter, so dealing with the fact that, for example, there are the explicit top level in imports and exports, and then there are the inline imports and exports that are represented directly on the AST node. So like on a function node, you can have a list of all of the names that function is exported under, which sort of adds to any explicit exports in the module, and that's just an artifact of the way that the parser works at the moment. And I mean, that's not very good. I think it's... I deliberately did it that way because I didn't want to get bogged down in worrying about it. But I think last time made it clear to me that that hack is making both the abstract syntax tree and the interpreter way more complicated than is strictly necessary. I could actually have a much simpler abstract syntax tree and therefore much simpler code in the interpreter that deals with the abstract syntax tree if the parser or the parsing pipeline or whatever was able to make some of those complications go away. So I'm now feeling more tempted to try having some kind of de-sugaring, de-abbreviating stage, some kind of pre-processor. Well, is it a pre-processor or a post-processor? Something that, I guess it goes before the parser, but would go after the lexer. So something that is able to, well, it would go after the S expression parser, basically. Something that is able to pre-process the S expression. I guess that's the way of thinking about it. Before it goes into the AST parser. So something that is able to... Well, I mean, at least initially I was thinking about imports and exports, but I suppose folded instructions are also in this category. I think that's a little bit more difficult to get working because you need to know about the arity of the static arity of the individual instructions. But I think things like the imports and exports... I think that's probably not that hard. I think to have a sort of a preprocessor phase that just rewrites the S expression to undo those abbreviations and turn them into explicit imports and exports, that would be great, because then the parser would only, you know, the only kinds of imports and exports it would need to deal with would be the explicit top level ones, because the abbreviations would have been desugared by the time they reached the AST parser. So I'm sort of selling myself on that. I think I was resistant to it before because I was concerned about, well, basically I was concerned about parsing being slow, despite what I say at the beginning of every single one of these streams about performance not being important. I'm conscious that the test run is quite slow, and I think that is mainly parser overhead, and I don't want to make it like an order of magnitude slower, because then it would just become impractical. But I don't think that's likely to happen. I think I can probably write a preprocessor that mainly doesn't change the AST. You know, it's not going to have to do a huge amount of allocations. It should be able to do quite a lot of structural sharing between the original S expression and the desugared one, because most of it is going to be unchanged, although maybe for instruction unfolding that's not true actually. But anyway, I'm sort of hypothesizing about a problem that I haven't actually seen in practice because it's only in my brain. So yeah, it's starting to feel more like that might be worth investigating. So that's the long story short. Maybe I could have a look at that. Depends where I get to with the table stuff, I suppose, because that feels like it's higher priority. Very briefly, 2 streams ago, the quality of the stream was absolutely terrible. Like 60 to 70% of the frames were dropping. Last time it was absolutely fine. I don't think I had any drop frames at all. This one, well, at the moment it's saying 0.6%. So hopefully this is going to be okay. So either whatever changes I made or whatever changes happened in the ambient environment, which includes my ISP and YouTube, has fixed that problem. Maybe I just got a dud server that one time or something. I mean, last time there was also nobody in the chat, which I can only assume was a technical fault of some kind. I mean, it can't possibly be that nobody is interested in this this gripping material. So I hope that YouTube have fixed their live chat so that we can have the usual party happening in the chat. There's no one there. Who am I even talking to? Doesn't matter. Doesn't matter. Oh, hello, Chris Zeta. Wow, you come to save me just right as I was about to descend into the despair of there being nobody in the chat. Hi, Chris. Very nice to see you. So I will do the traditional. Well, why don't we make this a tradition that I update the WebAssembly spec. Let's just see what has changed. So that looks like a change to only the human readable specification. Yeah, that's all just in document. So I think it's completely reasonable to expect that all of the tests are still going to pass, so that's good. While those tests are running, I'll just do some cleanup on this. Yeah, so lots of stuff to do with module instantiation and tables. Oh yeah, the register command, fleshing out ref func. Oh yeah, I forgot about all that. Yeah, function references, that was also a thing. Index parsing. Yeah, I think that was it. It felt like more than that, but it was just that. And I think elem.drop, yeah. So this was done. So I'm going to start by just cracking on with some more of these tests. But like I say, sort of tempted to think about parsing once I feel like I've earned it by actually making some test parse. So let's try. I don't think bulk.wast is going to be any different from before, because the problem there was always that we don't have this memory.fill instruction. Yeah, we still don't have that. I think it's probably quite easy to implement, but like I was saying, I guess last time I added table.wast here as something that might need looking at. But I've also got call indirect, needs proper LM support. I'm sort of hope that we have proper LM support now. So this might just pass. Hey, it's looking... Oh. Such an emotional roller coaster. Okay. I mean, that was quite good, wasn't it? It got quite a long... I mean, I don't know how many tests there are in this. Let's have a look. Okay, yeah. I mean, I'm definitely going to look at this. So, oh yeah, I've already got bulk in here. Okay, well I should get rid of bulk because I added it. Why did I? Sorry, I was reading it from there. That's not very helpful. Call indirect. I think probably I should do call indirect, and then I will just do bulk, because that's been hanging around like a bad smell for a while. I keep pushing things in front of it, but I should, if I'm going to do it, I should just do it, right? Let's make another tab. Okay. Add. What do we normally say here? Yeah. Add call indirect.wast to pending tests. That looks right. So what happens? So these all look like... So these are all type defs that are just specifying different types of functions. So these are ones that don't take any arguments and just return certain types of values. And these all take different types of arguments, different numbers of arguments. And here are a load of functions that all have those. These are all type uses that refer to those type defs. Nothing particularly interesting there. I guess this is the interesting bit. We've got a table that has an inline element segment that contains references to all of those functions. So it's already quite promising to me that a bunch of these assertions, I mean, clearly this is mostly working, which is a pleasant surprise to me. So the fact that it is managing to populate this table, And let's see, is that the only table? Oh no, okay. So this is the only one at the top, and then there's loads of assertions about it down here. And I mean, I wouldn't be super surprised if this was the chunk of assertions that was parsing, because everything I've seen so far kind of makes sense. The quantity here looks, actually, there's rather a lot of assertions there. I think I might be being overly optimistic. I was going to say it looks like it's the same number of assertions there as green dots here, but I think maybe I'm being too optimistic. But then again, I'm terrible at estimating, so that could go either way. Now here, right, well, this immediately makes me a little bit nervous because I honestly don't know whether I've implemented multiple tables. So just based on nothing at all, I would assume that probably all of the stuff with a single table is fine, and then the problem we're having is because we're just not, these element segments are targeting the wrong table or something. So this is invoke call 1 with the number 2, number 3, number 0, expecting a 5. That does look very much like this assertion, doesn't it? So even though I've still somehow managed to fail to do what Chris suggested, which was get line numbers into this thing, this does look quite convincing to me. I think that's probably a safe assumption. Why don't I just, rather than assume things, spec, test, core, call indirect, multiple tables. So I think it's this that's failing. Not really interested in all those assert invalids because I don't support that assertion yet, but let's just see. So I'm expecting this to immediately fail. It should be the first assertion that fails here. Yeah. Okay. So this is clearly, this looks to me like, well, I mean, this is obviously the wrong number, but this is either a negative number or potentially a float. Do we understand what's going on here? So this declares 3 tables. One of them point at F and G. Table 1 points at F and G. Table 2 points at H, I, and J. Table 3 is initially empty, but then we've got these element segments, these active segments that write G, H, and Z into 3 of the 4 locations in table 3. And then this call 1 called it with 2, 3, and 0 and expecting to get 5. So 2, 3, and 0, we call. So this is going to be the 2, and we're calling it with 3 and 0. So we're calling position 2 in table 1. I'm struggling to understand why it's this result, though. In fact, I'm slightly confused. 2, 3, 0. The reason I'm confused is because I I thought these were at position 0 and 1. Am I confused about how call indirect works? Because this looks like it's supposed to be... Like, maybe this is... Does call indirect take the index as its last argument? Like... Because it looks like this is supposed to be 2 plus 3 gives 5, and this is supposed to be 2 minus 3 gives minus 1. So I think I'm just being stupid and not remembering how call indirect works. Instructions. Control instructions. Oh, I have to look in here. Call indirect instruction calls a function indirectly through an operand indexing into a table that is denoted by a type index. Hold on. So that's the table index, that's the type index. Pop off the first yeah, I'm missing something here. What am I missing? I'm pretty sure that the first argument to call indirect is the index of the function to call. I don't know. I don't know how to clarify this. I must just be reading something wrong, but I can't see what it is. Invoke call 1 with these arguments 2, 3, and 0. And I think, you know, it's not like they go in the opposite order or anything. Like, they should go in this order. And you can see here, this is supposed to raise an exception, undefined element, if you say 2 here. So that's outside of the range of table 1. There is no 2th element in table 1. So this last thing is obviously the function index in the table. But this is saying local get 0, 1, and 2. I'm really confused about this. So here, call indirect. Oh, these are all just zeros. Um, it's hard to see it. There's definitely something that I'm misunderstanding here, because the index comes at the end. But I suppose that's just how it works. Yeah, maybe it's just, maybe I just never really thought about this before, but it does make sense. Yeah, I guess it does make sense. Because you have to have the function index on the top of the stack for call indirect to work properly. So yeah, it's maybe just, well, it was for me confusing to see it written out like this. But I think, yeah, it's just the sort of the folded syntax was doing my head in here. But we push 0 and 1 onto the stack, and then we push 2 onto the stack, and then when we call indirect, it's the 2 that's on the, well, it's this, not the number 2, the local variable 2 that's on the top of the stack. So I think, yeah, my brain was just freezing up there because I wasn't really thinking. But okay, that makes sense now. So okay, so why is the test failing is what I was trying to think about in the first place. I mean, my guess was going to be that this was writing the references to the functions g and h into T1. So h is multiply, but then it doesn't make sense. So I don't know why this is failing. Which means I'm going to need to debug it, but it's just a little bit disconcerting that I don't understand how this has gone wrong. So I think I'll have a look at what happens let's have a look at what happens during module instantiation. Because I think that happens during initialized tables. Oh, look. Yeah, so I think this is what I was assuming the problem was, is that it doesn't pay any attention to which table to use. So I think that would be consistent with my hypothesis that this was writing these into the table T1. It doesn't explain why this multiplication would return a big silly number like that, because the arguments are only 2 and 3. Oh, hold on. No. It's not H, it's G. So it's calling G, which is subtract. So I think that does make sense, because I think this is -1. Yes. Okay, all right, fine. All right. Well, again, my brain wasn't working properly. This is overwriting F with G, and so what should be an addition down here is becoming a subtraction, and the fact that it's showing it doesn't. We can't distinguish between. You can write a signed number here, but everything gets stored as an unsigned number, and there's not really any way to know. There's not any good way for me to automatically detect that that was supposed to be -1, because that's not stored in the representation in any way. Okay, so right, so why can't I just? I assume that this isn't on the AST. That if we look at elem, right, it's just got offset and items, and we need an index here. I think that in an element segment, though, it can have an ID. Oh, no, that's okay. I think it's okay to just have the table use here and have the index, because the ID is just going to populate the identifier context. We don't store it on the AST anywhere. So I think that's okay. So if it was possible to get the index on the element there, then this could just be well, I could just do element.index. Have we got any sort of defaulting to 0? Oh. Okay, never mind. How? I don't understand. Oh, I mean, maybe it was just legitimately telling me that there is none of that. Okay. An optional table index. A table use can be omitted defaulting to 0. So my temptation is to actually do that in the parser, right? To say that every one of these element segments always has to have an index, and then the parser will just default it to 0 if, you know, it's in the definition of parsing here. Oh, hold on. Yeah, no, that is what this is talking about. It's this abbreviation. So, you know, if I did have a preprocessor that expanded this abbreviation here, then we would get a literal 0 there. So in this imaginary game, let's say that the index is always present. And then everything will work perfectly. And the only fly in that ointment being, yes. In fact, that's quite nice, isn't it? It takes me straight to where the problem is. We need to have the index of the table. Oh, look, we already have it. So I mean, is it bad that I've just called this index? I think it's probably okay. So what I was saying was that we need this to default to 0. Oh, except hold on, what's this business about? Oh, if the table use is omitted, the func keyword can be omitted as well. So we have to make a decision. Oh, no, I think this was about... Yeah, sorry. This was about, just in terms of the grammar, if we have an explicit table use... Yeah, this is a bit funny. Certainly at the moment, it's true that if there's a table use here, then this must be an active segment. So that's what's going on here, is that if a table use was provided here, then it sort of forces the reading of the offset, and it would be a syntax error if there wasn't, if we couldn't do that. Yeah, and then this is the thing that says if the table use is omitted, the func keyword can be omitted as well. So, you know, I was just gonna do that, but actually I think it's important that we remember that the table use was omitted, because syntactically that has significance, or at least until I have a preprocessor that deals with this stuff. For now, I need to know that the index was omitted, and then I think, in fact, what I can do here, this can be table index or 0. So we can sort of default it to 0 at the last possible moment. It works. Nice. All right, cool. Okay, well, I think there's probably a couple of... I don't need that anymore. All right, well, that was surprisingly easy. So I think I want to add the AST node, and I think probably the AST parser too. Yes. And then there's a separate change that's actually make use of it. So this is remember table, let's say store table index defaulting to 0 on element segment AST node. And I will just narrate what I explained there. It's making me realize that what I've done is slightly problematic, because it sets a table index, you know, in all cases, and it's actually only in this. Let me finish this commit, and then maybe I might want to tweak it slightly. Store table index defaulting to 0. For now, it's important to remember for a little while that the table index hasn't been explicitly provided, since that enables, well, since that affects whether the table index has been explicitly provided, i.e. by allowing it to be nil if not, since that affects whether we're parsing an active segment. So actually, I want this to be 0, and this can be 1. Since that affects whether parsing an element segment and what abbreviations are available. A missing table index should default to 0. We eventually to 0 if it hasn't been specified, since that's the default. And I suppose that's the thing that I want to slightly finesse. Which is yeah, this is the point where we discover whether we're reading an active segment, right? So here we're definitely reading an offset. So this is where table index should be defaulted to 0, in my opinion, not down here. Oh. What the what? I don't understand. Oh, is the return value of this block important? Yes, it is. Maybe it should go there then. Yes, that was very silly. Now what? What have I done? What? I did something stupid down there. Okay. Right, that's the change I was expecting. Okay, so I just did some kind of, I screwed up in Vim is what it comes down to. So I think this will be only default element segment table index to 0 if it's active, if it's an active segment. Previously, we were always defaulting it to 0, but the table index is only meaningful and therefore should only be present for active segments, which are ones where an offset is provided. Okay, I think that's more accurate than what we were doing before. And now I'm pretty tempted to just say, to just rename that identifier to index so I can do the punning down here. Yeah, do I like that? I think I do. I think the fact that this is the table, the index of the table for which this element segment is destined, is fundamental enough that it doesn't need to be qualified with a prefix. I think I feel that way. Oh no. I've broken elem.wast. Let's just finish this. Do I want to finish this, or do I want to? No, I think I want to stop until I've unbroken the situation I'm in, because okay, so what's wrong with elem? Okay, where did this get broken? Okay. Okay, so it was when I did this. It's literally this change has broken elem.wast. How strange. I just want to understand that, because it felt like what I was doing here was principled and correct. Oh, hold on. We need it to still be nil down here. Okay, so this was too enthusiastic. I think I'll do it down here. Like, once everything is done, let's say table index or equals 0. What is it? Unless offset is missing. I think that's probably the right fix. Yeah. So right, so this was doing the cheeky rename. So I think both of those tests should be passing now. When I say both, I mean only one. What? Oh, hold on. Okay. Well, I'm getting myself confused here, aren't I? Let's take it one step at a time. I should just move this. Let's just do what I know. It was because I wanted to see the test completely pass, but I can't do that. I have to allow this to remain nil all the way through the end there. And then let's just leave it. Okay, call indirect is no worse, but elem.wast is now good. So let's just be happy with that. Right. And that's a much more local change anyway. So I think that's okay. And this is going to go away if I have a if I have a more systematic way of dealing with abbreviations, but this is just a consequence of the abbreviation right now. So let's clean up this mess. Okay, so now I've just got to get rid of this. Still got this one down here. Okay, so now I think both tests are going to pass. That's what I said before. Okay, that's actually correct this time. Okay. Let's just say rename table index local variable to just index. This is fundamental enough to the concept of an element segment. What is the index of the table being targeted? That I don't think it needs a table prefix, which is why I didn't call the AST nodes member table index. And it's better for everything to match up rather than have two different sets of names. Okay, so now this is the change I wanted to make, which is just, well, and I should remember that this also needs to come out now. So this is just use active element segments index when copying into to copy into the correct table. Okay, yeah. And there was a to-do there, so, you know, that had already been anticipated, not surprising, probably doesn't really need any explanation, I would say, probably. Okay, it's looking good. Okay. Needs proper elem support. You have it. Okay. Do I want to get derailed by bulk.wast? The problem is, I know, I'm sorry, I said I was gonna do bulk.wast, but surely table.wast must be close now. Not even slightly. Okay, let's have a let's have a look at this. Sorry, bulk. We'll get to you. I mean, really, what's happened here, the reason why bulk has been left alone for so long is because I think when we hit elem, that ended up being a very large sort of digression into getting tables working, and then call indirect was was easy once that had been done. So it's sort of still, I think it's sort of legitimate that we're still working our way through the consequences of getting elem working, and I think making table work is part of that. And table.wast appending tests. It's complaining about, it was expecting to find externref, and instead it's found 0xffffff. So let's see why that is. Interesting. Oh, this is, I think, because these are limits. So I expect that this is a manifestation of this problem, where because it doesn't recognize this as a number, it's trying to parse it as a ref type. So externref just happens to be probably the last thing in the pattern match, because it can be either funcref or externref. So I think it's saying I've got to the end. I've just tested it against the last possible pattern, and that doesn't match, so I'm raising a no matching pattern error. But I think what this is really saying is this should have been either externref or funcref, and it was neither. So I think, let's see, this is the ideal opportunity to do the thing that I already said I wanted to do, right? Parse table type. Parse integer if peek in. So didn't I write a flipping regular expression for this? Hex. Yeah, but the regular expression was for indexes. So I really need like an integer regular expression, don't I? Ugh. Oh, come on, give me a break. I wasn't even looking for the right thing. Oh, right. Okay. That was surprisingly annoying. well, let's say if we were just going to have integer regexp, it would be these two, right? Actually, it makes me realize that this should really be one of those. The reason why this wasn't here before, so this is like a non-capturing parenthesis, is because parentheses don't capture. Oh, same here. Parentheses don't capture. Oh, whatever, doesn't matter. They don't capture if you've got a named group, is what I was going to say. But why do I even care about that? No one cares. So where, because it's really D plus. How do I? Yeah, so there are lots of places where we're looking for decimal digits. I don't really want to think about which of those this should be affected by. So let's just do this for now. So I think this is going to fix the parsing error at least. Oh, well, it's given us a different parsing error. I think maybe this should be unsigned because it is a U, I think. Let's just look. Text format. Table. Table type. Limits. U32. So I think this probably should be unsigned. Because we explicitly don't, even though parse integer does support, I mean, this is really parse signed integer, I suppose, because it does support it does support having a minus sign. I was briefly confused about how this works, but now I see. So although this hasn't fixed the parser, I think it has progressed us onto a different problem, which is like a kind of progress, isn't it? Now this is saying it's found. Oh, this looks like there's some kind of inline import that we don't. Yeah, it's this. So we don't support this syntax yet. Okay. Well, one fix at a time. Let's say support unsigned. Wow. Add support for hexadecimal index literals. So let's say add support for hexadecimal limits in table types. So the reason I'm hesitating is I'm not sure. So this is when parsing limits. Like, is there a way that we can do this more comprehensively? Parse memory sizes. Right. So here we actually don't. Here we already do support hex because we just call straight into parse integer because we're able to. In the memory syntax, the limits are just the rest of the contents of the list that we're in, I think. So yeah, we're always at the end of a list, and so we can just parse as many, well, either one or two, but syntactically we're parsing as many as we can find, as many numbers as we can find, which does mean that we're able to parse negative numbers, which isn't quite right. So maybe we should make this a bit more explicit. Like, now that this exists, I think maybe it's better, rather than doing this repeatedly, to do this, which is to say that the minimum size is mandatory and then the maximum size is optional. I think this is stricter and therefore more like what we want. And I'm not sure where else limits is used. It looks like it is just in these two places, doesn't it? Memory types, table types. At least for now, I think I can live with that. And that means that, well, see, this isn't. Well, this is something like raise unless peek in. So if I'm just thinking about how do we make sure that we've read two unsigned integers here. And I think this is like mandatory unsigned integer here, and then optional unsigned integer here. And then if we weren't able to read this, then either we're at the end of the list as we're supposed to be, or we're going to get an exception thrown somewhere else that's saying like there's some bogus value somewhere where it shouldn't have been. So I think that, I mean, this isn't required to make any test pass, but I think that helps to sort of unify these two things. Although, you know, table type should work the same way, shouldn't it? I should just, what I should be doing here is just extracting a thing that parses the limits. So let's just do that rather than, let's take this back down here. Let's stash all this. Okay, so I think what we should actually do is have def parse limits, and that's going to do this, except why have I decided to do that? I don't think there's a good reason. So parse the limits, and then this deals with it. So I think this gets us to the point we were at before. Yeah, it's just extracting a helper here, but now we can refine the helper, basically. So yeah, this is still failing because of the unsupported inline import. So let's sort this out while we're in here. So this is extract parse table type helper. No, it isn't. I was reading the commit, but this is because gets confused. It's parse limits. Okay, extract parse limits helper. How can that, why is that, how can that be parsing? Because I've screwed it up. This needs to return an array. So frustrating, because I just really rely on tests to tell me when I'm doing something properly or not, and like the fact that I wasn't even thinking doesn't appear to have been a problem there. Okay, I think now it's right. Yeah, top tip, it's not enough to just assign things to local variables and then hope that they will magically be available in the results of that method. You do actually need to pack them up into some kind of data structure to return them. That's today's little Ruby advice. So yes, now let's be a little bit more, let's be a bit more strict here. So this is now make minimum size mandatory in parse limits. And I don't think I need to explain that. Why has that happened? Is there some kind of abbreviation that we need to deal with? Because clearly this level of strictness is not acceptable, because somewhere this is causing an exception inside br.wast. Okay. This is turning into a bit of a rabbit hole, isn't it? But let's just try and understand it. More parser nonsense. So parsing table type. Func. Table, func elem. Right. There is clearly no table type here. Under what circumstances is that allowed? So the limits is non-optional, but clearly it is optional. And that's when you've got an inline element segment. So again, this is an abbreviation. I don't know if we really care about the minimum and maximum size anyway, but in this case it is. This abbreviation does make it optional. So let's move this up here. I know it doesn't matter where this constant is defined, but to me it kind of makes it clearer to have it syntactically above the first place that it's being used. So I think this is trying to make it clear that if you call parse limits, then the expectation is that it's supposed to be there. And this decision we're making here is when we're parsing a table type, well, it doesn't really match up with the grammar, does it? Because with by the time you're choosing to parse a table type, you kind of know that there is one. So yeah, let's make the decision up here. So now this is going to be if peak in unsigned integer regexp, then this, else ref type equals, well, we don't have parse ref type, do we? It's going to be this, which is a bit rubbish, but I think that's what we need to do here. And I don't want to get too derailed into extracting more helpers at this point. But I think this is the right thing to do, is to spot that we're in this abbreviation situation and not call parse table type, because when we do call it, we've got to, that means that the limits are mandatory basically, because that's what the grammar says. And I mean, obviously I can do whatever I want, but I'm trying to keep it as close to the spec, just to help me to keep my head straight about what it is that I have done. So what is this? I think I'm just going to amend this previous commit. And let's say this in turn entails making parse, is it parse table? Only call parse table type when it knows the limits are going to be there, i.e. there isn't an inline element segment abbreviation. And let's just link to that. So that's a little bit, I've just sort of crowbarred that in there. But I think that's the necessary change to not break the tests. Okay, and then the thing I actually wanted to do here was to be able to call this here. So I think this parse memory sizes can probably go away. And this can just be parse limits. Parse limits. And I think, let's just think about this, but I think here, if we had been unable to read at least one integer here, then this pattern match would have failed. So I don't think it's possible for this change to break anything. Anything that was previously working should still be working, in my opinion. Use parse limits instead of parse memory sizes. And these do the same thing, but parse limits is stricter about what syntax is allowed. And stricter is better. Okay, so that's all dealt with. That's all dealt with. This looks like a relic of a bygone age. As is that. Okay. All right, stash is nice and clean. What the heck am I doing? Right, imports. Specifically inline ones. So this is the problem. We just don't support this import syntax. So I'm going to have to add support for it. And this is more parser shenanigans. Although I'm also going to have to implement the semantics of this. So it's also interpreter shenanigans. So that's fine. So here we're reading any exports that show up here, because looking at the syntax here, it's the same deal, where you can actually have multiple table optional ID, and then you can say export, 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 because this abbreviation can apply recursively, right? The 3 dots here survive this expansion verbatim, and so there's nothing to say that those 3 dots couldn't be a second export followed by a third export and so on. So we can like unfold these exports multiple times, but then you can only have a maximum of 1 import, which would have to come after all of the exports. So we've done all of the exports here, but now we need import. And I think I can probably just nick this from the various other places that I've just duplicated that code. I just noticed this was using pattern matching to destructure the minimum and maximum size. Oh dear. I need to sort my life out. So anyway, it's something like this. That's how it works for globals, at least. And then I just noticed that for functions, it's something slightly different, but I guess that's because functions are a nightmare. So it seems like if can read list starting with import is important. And then import module name, read list, blah, blah, blah. So all of that's the same. Import module name, read list, starting with import, parse string, end, import equals import module name. But now we've got this parse global type, else, parse global type, value equals parse instructions. Okay, so this is about the syntax of what can come after the import. So the else clause here is just whatever this is. You know, because when we've got an import here, we don't have the normal thing. We have something else. Well, the normal thing being table type. Yeah, because normally it's just like table, then the ID, and then we've got the opportunity for many exports. and then the import. Yeah, the reason I'm hesitating is because this elements equals parse table element. I sort of feel like this should be in there now, actually. Sorry, let me just think about this. Because if I'm going to be changing this code, I want to make sure I understand it correctly. So again, this is more complexity to do with abbreviations, unfortunately. But this is saying, after we read the ID, we're just ignoring imports and exports for now. So just focusing on the abbreviations we currently support. After we've read the ID, there are two things we can see next. We could either see table type, which necessarily starts with a limit, or we're going to see a ref type, which is going to be funcref or externref. So at the moment, this conditional is making that decision, but then afterwards we're reading elements, which is only something that we can do if we're in this abbreviation case. So I think this should be inside here, because those are the two things that we support. And the reason I'm banging on about that specifically is that in the case of import, it's only the former. We only do this, parse the table type. We obviously don't need to worry about there being an inline element segment, because the whole point of an import is that this table is not actually defined here. It's just a reference to a table in another module. So I think it's important to get our head straight here before we start trying to add support for imports. So let me just run this obviously doesn't make any difference. And I think the reason for that is because elements can read an empty array. So this could parse table element, I'm sure, just says repeatedly. Yeah. So both of those will happily return. If there's nothing there, they will happily return an empty array. But I think we do want to draw a distinction between an empty inline. So if we're in this situation, well, we do have to read elem though, don't we? So actually, it's this outer conditional that allows this to return an empty array. So this is what was making that whole shebang optional. Right, but this needs to, the interpreter needs to be able to cope with the fact that there isn't one. So that's sloppy. So let's make it cope. So here, this needs to be unless table elements nil. Well, I think we need something similar to this, don't we? Like, tables reject elements nil, each with index. Like, this is trying to find all of the tables with inline element segments. This is trying to find all of the explicit element segments that are active. And I think in both cases we need to, obviously we need to only use the ones. But each with index isn't going to work, is it? I was going to say we need to only use the ones that actually have inline abbreviations, but the problem here is that if we filter them out, then the indexes aren't going to be right. Let's just see if that, oh, which test was failing here. Stack. Oh, that has been a long time. Okay. Yeah, I suppose I can just narrate that in the commit message. This is yet another situation where we're having to do extra work in order to deal with abbreviations. So the interpreter, again, this is notionally the sort of the layer before the interpreter that deals with module instantiation. But, you know, it's still code that I've got to write, and at the moment it's having to do double the work here, first dealing with the abbreviated inline element segments and then dealing with the explicit element segments at the top level of the module. And this is just one more bit of fiddly detail. But okay, so that works. So what do I want to say here? Uncharacteristically, let's just go into the editor and think about what the commit message should say. So this is something like only parse table element when there's no inline element segment. Oh no, only parse table element only try to parse table element when we know there is one. Inline element segment when we know there is one. This conditional inside parse table tells us whether we're using the inline element segment abbreviation. And we only want to read elem in that case. So we should do that inside the conditional rather than always doing it. And let's say I've noticed that parse table element is designed to silently tolerate the absence of an elem, which isn't really right. I don't think this needs to be parenthesized. This is so I'll fix that in the next commit. Well, let's say which is no longer required. So I'll fix that in the next commit. Say something about annoyingly, I couldn't just use reject in initialize tables to ignore tables with no inline element segment, because that would have thrown off the indexes of the tables in the resulting array. So for now, I've just used next instead. Ideally, I'll find a way to desugar the abbreviations before they reach the interpreter, in which case all of this complexity will go away anyway. Okay. So I think I've now correctly got my head around what's going on. So let's resume. Yeah, it was silly to do that while the tests were running, wasn't it? So okay. So yeah, the point is that this conditional that's like if can read list starting with import puts us very specifically in this mode where we're only going to do the thing that is read the table type. And in fact, we do have to do that. If we didn't see an import, then we need to ask this question about are we going to see an inline element segment or not? But that question is not meaningful in the case of when we've done an import, because you can't have an inline element segment in that case for sort of semantically obvious reasons. So the else here is going to be this. Right, and I was a little bit confused about that before, but now I think I'm unconfused about it. So this is an import. We read the import. This should be this should be extracted. Oh, I've just realized. Sorry, I know I'm jumping around a lot here, but I've just realized my previous commit message wrote a check that I haven't yet cached, which is the parse table element thing. In fact, there it is. So I think I'm gonna just remove all that and make it so that you can only call parse table element when you know that you're supposed to be reading an inline abbreviation, an inline element segment as part of an abbreviation, and that is what we are now doing. So I'm hopeful that outer conditional was no longer doing anything. Oh, come on. Okay. Cool. Okay, so that's all failing in the correct way. Still haven't got that import, but I think we're ready to do it now. Remove unnecessary conditional from parse table element. This condition is now always true because we only call this method when we know we need to read an inline element abbreviation, inline element segment. So how now is this different from parse element? Elem item 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 I mean, it is quite different, isn't it? Okay, never mind. Never mind. Don't think about it. It's a subset of what you can do in a real one. So I don't think it's very useful to share that code. Is my summary. Okay. Yes, that's more useful, isn't it? Okay, so this doesn't actually do anything with the import, but it does parse it. Oh. Looks like this doesn't have a single... Right, this doesn't have a single assert return in it. So this is just checking that we can parse it properly. Well, I suppose I'll leave it there then. Like, I don't have any motivation to add that to the AST, although it does need to be done. I don't have a test that will tell me that I've done it correctly, so even if I do bodge it in, I'll probably make a silly mistake and it'll be wrong, so I'd sort of rather not do that. So I think I'll just leave it at this. This is include imported tables when instantiating a module. Yeah, that certainly makes it sound like it's important, doesn't it? So what's this then? Parse table import descriptions. Oh, right. So that's okay. Yeah, that's if you've got a top level import. What am I doing here? Yeah, parse import abbreviation and function definitions. So it's almost exactly the same as this commit message, in fact. So this is parse import abbreviation in table definitions. So now it's parse when parsing, e.g. table.wast. Which is now parsing And so therefore, we need to move this. Okay. So I've done this now. How have I managed to get away with not implementing table.init? That really surprises me. Table.get and table.set. Are there any other... I know I should look at bulk, but while I'm thinking table-related thoughts, is there anything else table-y? Optional table index for... I mean, I assume that this is a change that we've tolerated. Oh, look. There are lots of table tests. Right. Right. Okay. I think while I've got tables on the brain, I should just get through these. So there's table-sub, table-copy, table-fill, table-get, table-grow, table-init, table-set, table-size. Let's just deal with all the table things. But I'm going to get bulk out of the way first because I'm sick of having to talk about the fact that I haven't done it yet. Okay, so this seems to be... Well, that's all the table functionality, isn't it? It's what it seems to be. But let's just shut up, bulk. Okay, what's your problem? Oh yeah, memory.fill. Okay. So we're going to need a memory.fill here. Parse normal instruction. What's it actually called? Oh, I need to be in the parser. Okay. So I've already got memory grow and memory size. So these are nullery. Oh, they've got no static argument is what I mean. We don't have to consume anything else from the source, from the S expression. It just uses the operand stack. So instructions, memory instructions. Memory.fill, that is in the same category as everything else. So this can go here. I don't know what I thought I was typing there. How do you... It's a comma. Hold on. How do you do this in Vim? You can use F to find forwards. Is it capital F? Yeah, that's what I was trying to remember. Capital F to find backwards. A bit of Vim content there. I'm so terrible with Vim. Sort of embarrassing. But too late to worry about that, isn't it? Okay, we also need memory.copy. So let's say parse the memory.fill instruction, and then we're going to need copy. Yeah, that's the same business again. Yeah, sorry, I don't need that. Okay. Oh, memory.init. Okay. So memory.init takes a data index. So I'm sure that's going to be painful. What am I doing? It literally doesn't go there. It goes here. Memory.init. And then this is in memory.init. Context.datas, which I'm sure doesn't exist. Yes, unfortunately. Okay, well, let's finish, and then I'm gonna have to stash this. Did I not? I did not. So again, specifying the index. Okay, and then this is going to blow up because that doesn't exist in the identifier context. Okay, stash u. What do they actually call it in the specification? Let's just go with that. Is it called? It's called data. Types, functions, tables. Haven't got memories. Oh, hold on. Oh, no. That data's is... Okay, I was like, whoa! But no, it's not called that. And actually, I noticed that in the module, this is called datas. So I've got to keep that straight in my head. But here, I mean, I don't have to use these names, but again, I might as well. So types, functions, not funcs apparently, tables, haven't got memories yet, globals, locals, labels, type defs. So data comes between globals and locals, somewhat surprisingly. Right, so yeah, here it's not currently doing anything, so that's not going to be good. Oh, I realized that what I meant before was grep. So here, add tables index space to identifier context is what we're doing here. Add data index space to identifier context. And now this will at least sort of try to work. but probably not because that space is empty. Yes, and I also have to call it the right thing, don't I? Oh, okay, data.drop. All right, so this is good. We're getting somewhere. Parse the memory.init instruction. Yeah, now we need to parse the data.drop instruction. Actually, I don't know. Is that a memory instruction? Yeah, data.drop, and that is in the same category. So it's going to go here. And here. And here. What? I forgot to put it in here. Quite a lot of redundancy in there at the moment. I could do a better job of making those instructions declarative. Okay. So yeah, I assume this is, well, I don't know whether it's going to be a memory init or a data drop, but it's going to be here, I think. Oh, well. Yes. It's inside parse index that we get the problem, but yes, it's because context.data is not populated. Let's say here puts parsing normal instruction as expression. We'll be able to see exactly which instruction is causing that problem. Data.drop $p. Yeah, so we never try to put anything into that index space, so it is not surprising. So this is data.drop. Okay, so now we need to actually populate the index space. So we need to look in build initial context. And here we need to do data something. So what does it look like? So basically the same as the rest of them. Like this will do. So we read the ID, don't care about the rest, and then just make sure that the name goes in like that. Yeah, most of them go down that way. It's just some of them are more complicated because of reasons. Like type, yeah, it's more complicated because it's populating two different things there. But yeah, actually, there's a lot of duplication here, and the only difference is which index space it goes into. So there's a little bit of tidying up here that's like refactor build initial context to combine all of the cases which only differ in index space. All of the simple cases which only differ in index space, which is almost all of these. I think it's really just type. Yeah, I think maybe it is. And import. I mean, it just ignores export. So I'll say here, I think this might be everything except import and type. The question mark is important because I'm not very confident of that, but I'll leave that for now. But I'm hoping that this is at least going to give us a different error. Yeah, elem.drop, no matching pattern error. Okay, so that should be in table instructions. There we go. I can already see that this is gonna. It's just gonna add another one of these cases, another identical case to this. Okay, well let's add this. Ignore elem fields. Oh yeah, so it's like this. This is going to be populate data index space. So I think I am actually going to do this now because I'm, otherwise I'm about to make it worse. Might be sensible to copy the shape of this actually. Type goes, I mean the diff is going to be a bloodbath whatever I do here, so I might as well take this as an opportunity to clean stuff up. So I think this is all fair game. Import is going to need to be different because that's its own thing. Okay, forget that. What I'm going to do is remove all of the ones that aren't currently doing anything because they're just getting in the way. And ultimately, what this says is, like, this has essentially got an else clause in it, so we should just have one. So let's just keep the ones that are actually doing something. It was really the presence of export that provoked that outburst, because I'm like, why am I even bothering to have that there? This just needs... I'll leave import here because, well, just so I can keep this to do, basically. So is that, it was just those two? Peak, 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 type. So let me just run the tests while I think about the commit message here. But this is going to be something like combine yeah, essentially useless memory export and elem cases into else. Into default in build initial context. The spec, it's going to have to be this. Has an explicit else clause. Well, an explicit default case. So it's legitimate for us to, well, so it's better for us to have one here than list cases like export, which don't have any effect on the initial context. And then I'll reorder these to match this just for the sake of argument. It's pedantry really, isn't it? Type func table, no memory, global, no elem, data, import. Oh, they already are in order. It's just type. Reorder, build initial context cases to match spec. Let's say this is purely cosmetic. The order doesn't affect behavior. Okay. All right, everything is still green. Now, what I actually wanted to do was consolidate all of these, and now it's a bit easier to do. Table, global, data. That's it. So func table global data. So we need something like index space name equals. How was I doing this? I was doing this in parse normal instruction. Oh yeah, like this kind of business. Like this kind of business. I think maybe a hash is more appropriate because it's one-to-one, right? So I think this is okay. Oh. So what do we call this? Don't really want to call it an opcode. It's like field. Yeah, it's like, I don't know, field name, field. It's like field name, a sequence of fields. I don't know what to call that. I had the luxury of not giving it a name before. Oh, hold on. I can bind it here. Because that's the only place where I care about it. So this can just be func is functions, table is tables, global is globals, data is data. So that's a slightly wonky mapping. But then this just becomes index space name, so I think that's right. And that's actually, I mean, I know it's a little bit fancy pants, but I think this is a fairly simple change. You know, I've just squashed those 4 cases. So let's just say consolidate. Func table global and data cases in initial context. Okay, so what were we talking about? elem.drop. Okay, I was looking at this before, but then I got distracted. I'm going to leave this here because I'm probably going to want to come back to this. See if my computer can handle 2 MathJax pages at the same time. Okay, it's a table instruction. Oh god, look, all table indices may be omitted from table instructions. I'm not sure that I'm ready to support that. Backwards compatibility. Okay, well, I'm probably going to have to deal with that shortly, aren't I? So, noted. elem.drop. Okay. So it's another one of these. But this is yet another index space that is not yet implemented. And what does this call it? elem. I don't really understand why some of them are plural and some of them aren't, but that's the kind of thing that I can go through and clean up later when I'm not having to pay quite so much attention to the specification to keep my head straight. Okay, well, this is ostensibly a nice kind of let's add a feature, but let's add an instruction, but I think this is going to fail because of the elem. So let's stash that for a second. So where does it go? After globals, elem. That was not helpful. Elem, empty array. Okay, so hopefully now we have a different problem. Yeah, so again, it's going to be because that elem index space is currently uninhabited. So let's say add elem say element index space to identify context. I mean, should I? Like, how much attention should I pay to these names, basically? It looks like, oh, apart from functions, that's the only one that doesn't match. So I guess I'll stick to the naming convention for now. And this is parse the elem.drop instruction. And then I can already see that we're going to have to add support here for elem. So after global, elem, yeah, so I mean, there's mismatches here, right? This should be called funcs, but it's called functions. Func to functions, table to tables, elem to elem. And we add it in here. So hopefully now we'll get a populated initial context. Key not found, elem.drop. Oh, I didn't add the support for it properly here. Sorry. That was an oversight. But at least that means it succeeded in looking it up. Yeah, okay. So that should have gone in here. parse the elem.drop instruction. Populate. What did I say? Element. I don't know why I'm inventing yet another dimension of what I'm calling things. But for data, it felt okay to call it data, but this I do want to actually use the human word element. Okay, so now we've just got another instruction to implement. I mean, this bulk.wast is turning out to be a nightmare, isn't it? I should have stuck with tables, but it's okay. Okay, table.copy. I mean, these all seem germane for tables, so I don't mind so much. Table.copy takes 2 table IDs. Yeah, let's do it down here. So obviously not actually trying to parse those yet. And I mean, arguably, I didn't need to parse any of the other ones, but it's just the... my hand was forced by the fact that I've consolidated all of these things that look up one index in an index space into this section of the case, and like I have to provide an index space, whereas down here I can get away with just skipping over, just like I am with table.init. So hopefully that's going to parse successfully. Oh, what have I done? It's a syntax error. What did I do in AST? I don't understand. Ugh. How? I will watch the video back later and try to understand how I managed to do that, because I don't understand what just happened there. Okay, right, so now we're getting runtime errors, which is good. We have successfully parsed this file. Parse the table.copy instruction. Okay. Done with the parser. Hopefully haven't broken anything. So now I've got to think about an initialize memory. Okay. So probably, well, we're not done with the parser, are we? So we've ended up with we're trying to evaluate a nil expression. Interesting. Right. Okay. Well, at least everything else is working. So it looks like it's the very first assertion in bulk.wast is causing the problem. I don't know that I've ever looked at this file. So invoke fill. Oh no, hold on. So we haven't even reached the assertion. This is happening during instantiation. Name equals nil. Functions is empty. Memory equals data. String equals foo. Right. Well, correct. It doesn't have an offset. You're quite right. Feels like it probably should, though, because I'm sure that this is supposed to default to 0. Let's just look at what the parser says. So, or what the spec of the syntax says. So this is a data segment. Oh, right. Similar situation where I guess the only ones I've seen so far were active. So this is very similar to element segments, which can sort of auto-populate tables. A data segment can auto-populate a memory, and I think so far I've always assumed that they do. But clearly, somewhere along the line, I've allowed offset to be optional. But the interpreter has somehow never encountered a module where the data doesn't have an offset, because it's trying to initialize the memory from it, which it shouldn't be doing. So this needs a similar reject to this, right? Datas.reject offset nil. And yeah, the reason it doesn't need memory instance is because there is only one memory, which is a bit naughty. But it appears to be working for now. Right, so this is the element segment version of copying itself into a table, whereas this is the data segment version of copying itself into a memory, because the API for memories is different to the API for tables, but it's pretty much the same deal. Oh yeah, so I was just pausing to understand. For element segments, the items can be, I don't know if they're arbitrary expressions or constant expressions. Probably constant. But nonetheless, you have to evaluate them, whereas for data segments, it's just strings, so there's no evaluation needed there. Okay, so I think that will fix that problem, which it has. But so we've successfully instantiated all of the modules. So it's something like this, right? Only try to copy active data segments into memory. So I should have just copied this whole thing. So this should be data segments. Okay, so I mean, at some point, what we need to do is to be able to, you should be able to ask whether they're active or passive, or ask what their mode is, or the active and passive segments should be stored separately or represented differently, because, you know, any active ones even have an offset. But, well, here the mode itself, yeah, in the sort of, in the algebraic data type that they're using in the AST here, they're saying like a data segment has a string and then it has a mode, and the mode is either just this sort of single, you know, it's this sort of unit value passive, or it's this active is sort of this record that includes a memory ID and an offset. So that's something that I should clean up at some point. So let's say clean up AST representation of element and data segments to store an explicit mode containing the appropriate values for that mode, e.g. offset index. So this is like table memory index. So that'll just make the code a little bit more explicit, because at the moment, like, this is, what is this even asking? If this was saying data's select where mode in active, that would be a lot more meaningful. Why is there a space there? I was going to say I didn't type that, but obviously I did in some way. But what I mean is, I didn't mean to type it. Okay, so evaluate instruction, no matching pattern error for memory fill. Fair enough. Memory instructions. Memory.fill. The memory.fill instruction sets all values in a region to a given byte. Great. How does that work? All right, well, I'm going to have to look in here, aren't I? Like, all I want to know is, like, what arguments does it take? But because they come from the operand stack, none of the information about concrete or abstract syntax answers that question, so I've got to dig around in here like a chump. Memory.fill. Okay, well, let's just look at, quite often this, the sort of specification of the small step operational semantics down here is easy to understand than this kind of completely bonkers list of 21 things to do. Like this, having it written out sort of declaratively like this, even though it requires a bit of mathematical squinting, is usually easier to understand. He says, of course I don't know what any of these things are, S and F and so on. So what's a vowel? Okay. Why don't I just read the code? this is always an easier option. Okay, invoke fill. You give it a number that looks like it could be an index. You give it something that looks like it could be a value. You give it something that looks like it could be I don't know what that could be. A length or an end index. In fact, yeah, let's think about this. So it looks like this, well, these assertions are very instructive, right? Because we start out with a memory. Oh, okay, yes, this one, memory.fill. So we start out with a memory that is initially empty. This doesn't get populated by any kind of data segment or whatever. In fact, this was just testing the syntax. It doesn't matter what the result of instantiating those two modules is. So we get a module with an empty memory, and this is just a way for the assertion to be able to call memory.fill. It's being wrapped in an exported function, but this is just, you know, this is just delegating to memory.fill, but we don't have anything as fancy as currying or whatever, so we have to explicitly list everything out for the sake of the type system. And likewise, this is just wrapping load an unsigned 32-bit integer from memory. So this is saying that in a memory that was initially empty, we should find the value 255 at memory locations 1, 2, and 3, but not at memory location 4. So it's very tempting to treat the 1 and the 3 here as being the sort of start index and end index that you want to be filled. And that is sort of consistent with what this is saying, is that there has to be a 32-bit integer, and then this val, and then another 32-bit integer, d and n. Oh, this makes it look like, I think n is probably the length rather than the index, so it's a little bit annoying. Okay, it's fine. Like, this isn't, these tests aren't supposed to be, you know, they're not supposed to be teaching you the semantics of WebAssembly, but actually it would have been nice if this had been like 2 and 3, and then we would have seen it fill 2, 3, and 4, and then 5 would have been empty, if I've understood this correctly. Whereas here there's an ambiguity because 1 is a special number, and it could have meant either. Anyway, that's irrelevant. I'm sorry. I don't know why I'm saying things like that. So, yeah, slightly annoyingly, these, but perhaps necessarily, these small step semantics are sort of dealing with all the edge cases first. So now I understand that this is saying if the index plus the length is longer, if that goes off the end of the memory, then throw an exception. If the length is 0, then don't do anything because that's a no-op. And then this last one here is the actual meaningful one. So this is saying okay, so this is recursively unwinding memory.fill into, so what this is saying is, this is saying replace the memory.fill instruction with a call to i32 store 8. So it's saying store whatever this value is, store it at D. Oh, hold on. So N doesn't get decremented here. Oh, I think that's a mistake. Because this says push the value i32 const n minus 1 to the stack. So I think I should open an issue about this because this seems wrong. I think in this unwinding, what it should be doing is saying we increment D, the offset, by 1, and we increment N, the length. We decrement the length by 1. So we still end up with a memory.fill instruction, but the length has been decreased. And so eventually, after n unwindings of that memory.fill instruction, n is going to reach 0 and we're going to have this no-op. So this is just well, I was going to say contrived, but this is sort of a mathematically convenient way of expressing the semantics of memory.fill because we don't have to get into the detail. We're sort of delegating it to i32.store8. Which just stores, I mean, presumably yeah, it's supposed to be a single byte, right? Like the whole memory is byte oriented. So, okay. Now I understand what it's supposed to do. So now we need to implement it. So in memory.fill, and yes, the instruction itself doesn't contain any, doesn't have any immediate arguments. So stack.pop3, and it goes to offset value length. I'm not going to do what they suggest, which is rewrite the list of instructions to make this, to put store 8. That would be madness. But just remind me, how does storing work? Something like this. So if I were to call that, obviously I could extract a little helper to do this, but I'm not going to. Current module.memory.store. Value I've already got. Offset. Okay, well that's... Yeah, this sort of needs to be like... Let's call this base. And it needs to be like length times do offset. It's going to be current module.memory.store value offset is base plus offset, and bits is memory bits per byte. Let's just check and see whether there isn't an easier. No. I don't have, I don't have a fill implemented here. I mean, obviously I could do that, but for now I've sort of implemented it here. I actually sort of prefer calling this offset and calling this index. Doesn't matter, of course. But apparently that's what I want to do. Ooh, look, some assertions passed. Okay. All right, so we're doing something useful. So I'm going to need to link to this. Implement the memory.fill instruction. Slightly unusually, this instruction takes a memory address, a value, and a length as arguments from the operand stack. And copies the value into that address, copies the value into, and repeatedly copies the value into memory starting at that address. It might be desirable to implement memory.fill or similar, but this will work okay for now. Well, but this implementation in terms of the lower level memory.store works fine for now. Okay. All right. Now, what fresh hell is this? Memory copy. Memory copy. Memory copy. Again, doesn't seem to take any immediate arguments. Let's use our newfound skills. Like here, I had to basically, well, I suppose I worked out how it worked by looking at the test. So here, well, now my brain is primed to actually understand this, because previously I just wasn't grasping the fact that it was actually, you know, unfolding that instruction into multiple instructions. But let's see. So this is the exception case. This is the base case that does nothing. I mean, in any case, it looks like it takes 3 arguments. It takes a D, an S, and an N. So it's very tempting to read these as destination, source, and length, essentially. But I don't know. But that's a strong hint. So if the source plus length is out of range, or if the destination plus length is out of range, then raise an exception. If the number of things to copy is 0, then do nothing. Right, so here we're, oh, hold on. I missed this. It is not a mistake. This, it's my bad. I apologize. It was not an error. It was just written differently than I was expecting. So the 1 gets subtracted from n by making this definition here be in terms of n plus 1. So n is either 0 or it's a positive integer here. And if it's a positive integer, then n is actually the predecessor of the integer that appears here. So I take it back. I'm glad I didn't I'm glad I didn't open an issue, because that would have been embarrassing. But the only reason I spotted it here is because it's repeated, and this repetition attracted my attention, and I was like, oh, that's interesting. Why is that there? And it's like, oh yeah, well, that's the obvious way to make this work. but it's just a little strange that the n here doesn't correspond to the n in the instructions. So I'm not sure whether I would have done it that way, but that's irrelevant, isn't it? Because I didn't write the specification. So why are there two cases here? And what do they mean? So this is if destination comes before the source, and this is if the destination comes after the source. So right. Right. Yes, that makes sense. So the thing we have to be careful with, well, it depends how we implement it, doesn't it? We don't have to be this picky, actually. But the thing we have to be careful about is the possibility of these two regions of memory overlapping, right? And if they overlap, then there's a risk. And the risk is that, as you know, if you're copying values out of the source, then if the destination overlaps with it, then you might have overwritten some of the source. So if let me make sure I get this the right way around. And also, what I'm mainly thinking about is what the camera is doing to the image of me, but I think this is correct. So if the source is earlier than the destination, then we need to worry about them overlapping in this, like this. So if normally what we would do is just start at the beginning of the source and just copy all of the values out of it into the destination, if the beginning of the destination overlaps the end of the source, then we're going to start copying stuff from the source, and it's going to be copied into the destination, which is also inside the source. So by the time we get to that region of overlap, all of the values that used to be there in the source have now been splatted by the copy, and that's not what we want. And the solution to that problem is to copy them in the other direction. So if we copy them starting at the end, then because we know these two regions are the same length, we know that if, the pathological case is that they're that the destination is directly on top of the source, but just ignoring that, which also works fine, let's just assume that it's further on in memory, then you do start splatting values you do eventually splat values in the source, but not until you've already read them, because you're filling up the destination from the end, which is past the end of the source. Like I said, because the destination is the same length, we know that the end of the destination is after the end of the source. And so when we start splatting the values in there, that's not affecting the source initially. And then once we've read far back enough in the source that we're writing far back enough in the destination that it's starting to splat the values in the source, that's okay, because they've already been copied to the destination by that point. And all of that, well, if they're the other way around, then you have to do it from the beginning rather than from the end. But if they're the other way around, then that's copying from the beginning is probably what you would have done anyway. So I think that's what these two cases are saying. You can see in this case that if the destination starts before the source, or in fact, if they are the same region of memory, then we copy from the left-hand end. Is that what I said? Yes. Yes. So if the destination starts before the source, then we copy from the left. If the destination starts after the source, then we copy from the right. And what that's saying is that this d plus n is computing the address of the final element in the destination, the final element in the source, and then we, each time round, we reduce the value of n so that we're sort of going from the end back to the beginning. If we do it the other way around, then we're actually, we still decrement n each time, but we don't add it to the destination and source. We always use the first element of the destination and source to do the copy, and then we increment, when we sort of unfold this instruction, we increment the destination and source addresses. So as the length is shrinking, the beginning is moving up to catch it. So the thing is kind of shrinking from the left as opposed to shrinking just in length, which makes it shrink from the right. So that all being said, I should just think about how I want to implement this, because I mean, yeah, I really didn't need to do that whole digression, did I? Because I'm a lazy Ruby programmer, and so I think I'm just going to take a copy. Is that right? Or should I do what they've done here? I think I'm just going to take a copy for now. I'm sorry. Because this is all predicated on the idea that you don't use any additional storage. So this is like an in-place memory copying algorithm, right? And the fact that it's in place means that you don't have some kind of magical other area, because you can ignore all this if you say, oh, I've got some area in the sky where I'm first going to copy all of those values to, and then I'm going to store them, because then it doesn't matter what gets splattered when, because you've taken a complete copy. This is predicated on the idea that you do it in constant space, so you're not inventing some, if the value of n here was 1 billion, you're not inventing another memory that's got 1 billion, locations in it that you can use as a temporary store. But inventing memory to use as a temporary store is exactly the sort of thing that you do in a high-level language that's got garbage collection in it. So the temptation here is to just simplify the implementation by just taking a copy. I mean, I do still have to iterate load and store, so it's a bit bad. I think what I can do here is length times map index current module memory load, what is it, offset and bits. Oops. So that will, I mean, this is very wasteful, but let's see if this works. Pull out all of the bytes, one at a time. I mean, you can, in both of these cases, you can see that it would be handy to have these as sort of low-level operations on memory. And, just like bulk operations in general on memory. Oh, I guess that's why this is called bulk, isn't it? Because I sort of assumed that there was some kind of bulk instruction, but I think it's just a categorization of all of these sort of bulk operations on memory. So I think it will make sense to push these down into the implementation of memory at some point, just to make them faster. But for now, I think this will be fine. So I've got all the bytes, and now I want to do, again, sort of separately, length.times.each. Oh, length.times do. Each would have worked, but you don't need to. Current module memory store. Oh, this isn't right. It's bytes each with index do value index. Maybe I'll call this values, just because I want it to be called value inside there, so that I can do so I don't have to repeat it there. Offset destination would have been quicker to type it, plus index bits memory bits per byte. So all of this business about having to specify the bits per byte, I think, is sort of an indication that these should be low-level operations on the memory, because the memory is byte-oriented, and this interface here with load and store is designed to accommodate multi-byte values, and it deals with endianness and all of that kind of stuff. But for these bulk operations, we just don't care about that stuff. We want to do byte-oriented operations, and so this kind of, I don't know what you want to call it, feature envy or inappropriate intimacy or whatever, like, we're reaching in and knowing things about how many bits there are in a byte, essentially just to subvert the multi-byte endianness support in these operations. So we don't really want them. But I think this is an acceptable implementation of memory copy, or at least one that works. Is that borne out by the tests? Yes, apparently it is. Okay, great. I mean, this is kind of fun. This is a bit of light relief. These are relatively easy to implement compared to all of the other stuff. I was just thinking about whacking these end to end rather than having the local, but I think it's probably okay. I think it's probably better, is what I mean, to have it separate there rather than building a big old chain of blocks. You know, it could call each after end here, but I think that's just cleverness for its own sake, and it's not even clever, so I won't do that. Implement the memory.copy instruction, and I'll say the specification uses constant space memory copy algorithm, which checks whether the source comes before or after the destination in memory. Let's link to that. I don't need to say memory copy. That's literally what the instruction is called. Oh, how did I... Somehow I managed to copy the wrong URL there. I don't understand how I did that. The specification uses a constant space algorithm which checks whether the source comes before or after the destination. Yeah, address is before or after the destination address. For the sake of simplicity, I've ignored this and taken a full copy of the region, loaded a full copy of the region before storing it. This might turn out to be too slow. As with memory.fill, it's probably desirable to implement memory copy directly rather than doing it all through load and store. But I'm focusing on making the tests pass right now. Okay. Cool. Memory.init. I mean, let's just see how... I was going to say how far through this am I, and the scroll bar would suggest not very far at all. Memory.init is arguably halfway. So if I can do memory.init, then I've got somewhere. Okay. So that does, well, memory.init appears to take an index, or at least in the AST, it's got an index. What's memory.init then? Oh, here it is. Oh, data. It's a data index. Okay. Memory.init instruction copies data from a passive data segment into a memory. I wonder why it wasn't in memory instructions. I mean, maybe it was. I don't trust the search. Yeah, there it is. For some reason, my URL hacking didn't magically find it. Okay, so this isn't completely straightforward. This also has destination source n, but we don't have to worry about this. Just does straightforward recursion. Again, yeah, left to right, just copy everything in. So yeah, I wasn't sure what arguments this was going to need, but I guess it makes sense that this is, you don't have to copy the whole data segment. Yeah, so S plus N has to be in range for the data segment. D plus N has to be in range for the mems segment, for the memory. So, okay, it's going to be pretty similar to this. Or at least that bit is. Memory.init, destination source length. So, I mean, this is going to be the same. So, good job I kept it in a local variable, but the way we compute this local variable is going to be different. So does this all, is this all okay? Like, does it know memory.init, context.data? Yeah, I guess this is all, I mean, I wired this up. Like, did I just wire this up? I can't remember whether data was one of the, oh yeah, it was. That was one of the index spaces that I just added. So I think I've already arranged for that to be, yeah, okay. Okay, so that should all be valid. Now I've already done the thing, initialize memory. I've already done this thing. Oops. I am really doing a terrible job of editing today. I don't understand why Vim is being so obstructive. Right, so a data segment just contains a string, doesn't it? In fact, does a memory just contain a string? I can't remember what the underlying representation of a memory is. Bytes. Yeah, bytes is also a string. But given that we're interacting with this from the outside, and a data segment doesn't have any clever stuff, it just lets us access its string. So anyway, the point is, first we have to get the data segment, don't we? So we have to say current module. Oh, do we keep them around? No. We don't. But we're going to need to, because the passive data segments need to exist at runtime so that we can use memory.init to copy stuff out of them. So what do modules look like in the AST? I think maybe I've sort of given up on this, but yeah, it's called datas. What I've given up on is having them in the same order, I think. This is just in a completely zany order. So module is going to need datas on the end here. So what I'm doing here is making it so that when the module is instantiated, we remember all of the data segments so that when we come to implement memory.init, we can say current module.datas.slice index to get the right data segment. And then all I've got to do is get the values. So what I want is like an array of bytes from the string. In fact, I can do it all in a single loop here, can't I? I don't need to store it in an intermediate array because I don't need to take a big copy in the sky. I can just safely iterate over. So maybe that's the right thing to do, is like, how do I... a slice of a string is a substring that is selected by certain criteria. I want a byte slice, though. Byte slice. Well, there you go. Or I can just do get byte at a given index. I mean, byte slice is what I really want, if I'm honest. can I trust Ruby to not duplicate the string if I do byte slice? I suppose that is invisible to me. Yeah, I mean, that's, you know, Ruby implementer's problem, right? So data, string, byte slice, and what are the arguments? Index, length. Perfect. Source, length. Value, index. Value, offset, destination plus index. I mean, I think that might be right. Like, that's slicing out the right number of bytes. I mean, there's no range or anything in here, is there? No, because really I just want to say each byte in this range, but I'm just hoping that this is, I mean, obviously this is semantically equivalent to that, but I'm just hoping that that's true with respect to side effects and stuff. Like, I don't really want it to allocate a whole new string here. I just want a view into the bytes in that string, but I'm just gonna let Mats worry about that. Oh, right. This actually is just a string, so I do have to specify each byte. Is that what I had before? Yes, each byte with index. So same deal. Yeah, I mean, this is pretty similar to what I was doing there, but, you know, crucially, doing a different job. Okay, I think that's more tests again. Yes, great. All right, well, these bulk operations are bulking out. So this is store data segments on runtime module representation. Sorry, Etienne. We need the passive data segments at runtime because memory.init, because the memory.init instruction can copy bytes out of a passive data segment into memory. So let's say, although well, hold on. What I wanted to say was, although active segments can only be used at module initialization time, but I don't know if that's true. Yeah, look, a memory init instruction copies data from a passive data segment into a memory. Data.drop prevents further use of a passive data segment. So I think I can say that. Although active data segments are only needed at module instantiation time, we need I think that's good enough. Let's say at some stage we'll probably want to throw away the active data segments at this point rather than storing them indefinitely, even though they've already done their job. Okay, so this is like clean up active data segments after module initialization. Sorry, instantiation. Only passive segments can be read by memory.init. Okay. Implement the memory.init instruction. I'm not sure I have anything useful to say about this. I think it is what it is, as so many wise people so often say. And now I have added myself to their hallowed ranks. Okay, just got to keep going. Data drop. Well, so we know what data drop does, which is to say essentially nothing. It's just a hint. I imagine that the tests are only going to verify that it's going to have a cert trap. Yeah. So it's okay to drop. Oh. Hold on. You can call memory.init with an active segment. That's very naughty. All right. Well, then what I said was wrong. Okay, well, maybe the specification should be slightly clearer on that point. Let's just move the word only. Although only active data segments are needed at module instantiation time. We need the passive states at runtime. The wording of the specification so where is it here? The memory.init instruction copies data from a passive data segment into a memory. Makes it sound as though memory.init only works with passive data segments, but the WebAssembly test suite makes it clear that active data segments can be used too. Let's just see if the init instruction, which I think I was previously looking at, says anything about it. Yeah, this doesn't mention the mode at all. So it seems completely legitimate. Let's just pick a version of this that's not going to be changing. Draft 1. I think that's what I want to link to. This assertion that shows that invoking init active doesn't trap. You only get an exception when you go out of bounds, because there's only a single byte in this data segment. But it seems to be completely legitimate. So all right, no, I don't want to actually be stuck on draft 1, but that will give my URL some longevity, I think. Okay, so that's a potential piece of feedback for the spec, I think, but it's only about prose, so it's not super important. The spec does actually make it pretty clear, as long as you don't pay too much attention to the actual phrasing of things. But literary criticism is always makes you come a cropper when you're trying to implement stuff, in my experience, so probably best avoided. All right, that was all about going back and changing a commit message, wasn't it? So nothing has changed. Okay, so I think the point of that is that I think I can just treat data.drop as a no-op for now, because all of these invokes and I am realizing now that this is all happening after a drop. But I think it's because... Oh, right, yeah, I wasn't thinking properly when I dismissed this before. This is saying if you actually try to read from it, then you get this out-of-bounds memory access. So I don't think this does necessarily... Oh, no. Have I misunderstood? I'm not sure that this is showing a successful init passive. Sorry, init active. let's look at this. Oh, this has only got a passive segment. Well, no, I'm a little bit confused, but I do think that this makes it fairly unambiguous that, and you know, unless the detail is squirreled away somewhere else, you know, that this data address unless this was only populated with passive instances, I guess is what I'm saying. Yeah, well, I'm just gonna not fixate on that for now. Anyway, the point is that I don't implement a cert trap. So this has been a very lengthy way of me saying that I can just implement this as do nothing. So that takes an index. So this is potentially throw away data's slice index to save memory, basically. But I think that all of the assertions I support are going to pass. Yeah. So that I just got some. Well, I think I did get some greens, mostly yellows. So I'm just going to say that this is used as an optimization hint. Well, I mean, why don't I just do it? Why don't I just do it? Current module data's index equals nil. Like, that was easier to type than the flipping comment saying that I was going to do it one day. Right. That's interesting. So here we can say, like, does anything in here do like an early return? No. Well, let's not start that now. Let's just say unless length 0, right. So I think I am actually gonna, I'm just gonna make that implement the memory.init instruction. Oh, I Did not mean to do that. Well, I should have. I didn't need to. I didn't need to be an amend, did it? I could have just picked the original commit. What I meant to say is to make a new commit here. Implement the data.drop instruction. And then I'll say the spec says this is intended to be used as an optimization hint, and the memory used by this segment may be freed. I think that's as good as it gets, unfortunately, for that URL. The spec says it's intended to be used as an optimization hint. The memory is freed. So we can, in principle, free up the segment's memory by replacing it with nil and allowing it to be garbage collected. I expect in practice that everything is still hanging around as part of the AST. But that hopefully won't be true forever. There was something else I wanted to say here. Oh yeah, about this change. To properly support dropped data segments, we need to tolerate memory.init when the length is 0, because that doesn't actually try to read the dropped segment or try to read the segment. And therefore shouldn't cause an exception, even if the segment has been dropped. Okay, good. All right, how are we doing? Table.init. Test that the data segment init is properly encoded as an unsigned, not signed LEB. Well, who's testing that? I'm not sure. This. Oh, I suppose this is testing validation, but I don't have validation. I only have runtime assertions, so that's sort of irrelevant. Okay, so table.init. how similar is this to something that we've already done? We must be able to pick up the pace on this because I've basically done all of the interesting stuff already. Table.init. The table.init instruction copies elements from a passive element segment into a table. The elem.drop instruction prevents further use of a passive element segment. Okay, well, I'm not sure why table.init is in bulk.wast, but whatever. I suppose it's bulk access to a table rather than to memory. Okay. Right, so there's a nil. Right, so I'm clearly going to have to start caring about these values. Table index, element index is what goes there. So I should expect to see a problem in the parser now. Yep. There we go. Already forgotten. Table index, element index. Yeah, I suppose it's going to be this, isn't it? Table index equals parse index. Context.tables. I mean, I'm already doing something like this somewhere else. Yeah, parse index context.tables. That seems to be real. And then it's called elem, isn't it? So it's going to have to be something like that, I'm afraid. What? What's going on there then? Element index. Table init. Doesn't say anything about, oh, it's because I'm not looking at the, I was like, there's nothing here about abbreviations. It's because I'm not looking at the concrete syntax. Let's look at the concrete syntax. That's a bit more important, isn't it? For backwards compatibility, all table indices may be omitted from table instructions, defaulting to 0. So oh, this is so annoying. So, yeah, I mean, I've got to do something about this, haven't I? Because this is such an annoying abbreviation, because it means that the first index you read, you don't know whether it's a table index or an element index until you then try to read another one. I mean, this whole system of abbreviations is extremely naughty, because for them to say that table.get is an abbreviation for table.get 0, abbreviations are recursive, so that means that table.get is an abbreviation for table.get 00, which is an abbreviation for table.get 000, and so on. So this is basically bad. But such is life. So how am I going to deal with this? This is really annoying. I'm afraid I basically can't use parse index is what it comes down to. I'm going to need to I'm just going to need to like re-implement it. So, okay. So we can always read this. So if peak in index regexp, then we can read the element index. So to do it's like set table index, else from index you know, table index equals 0, set element index from index. So that's going to be this, basically. Element index equals this. The index space is context.elem, whereas here the index space is going to be context.tables. Very annoying, but sort of unavoidable under the circumstances. I mean, I need to factor this out better, don't I? You know, I need to like extract a resolve index or similar helper for looking up any index in any index space if it's an ID, or turning it into an integer if it isn't. So what am I doing here? I mean, I don't even know if this is right, do I? I mean, is that... Yeah, I mean, look, classic default table. You scamp. So that we're getting dangerously close to the end of this now. Table copy. Okay, so I think I'm gonna get this bulk done. I thought bulk was gonna be simple, but that was naive of me. So let's say okay, well I'm not getting any help from my commit history here. Let's say parse table and element index or indices. When parsing table init. Let's say store. And I think this does need some explanation. This is unnecessarily complicated because the table index is optional. Resolve index helper or similar would be helpful here. Let's call it useful to avoid repetition of the code from parse index. And we can't directly call parse index. Well, let's say so we can't directly call parse index because, well, since we don't know which index space the index is in until we try to read a second index. Well, this motivates a different paragraph to avoid getting the pound sign at the start of a line. Hash sign, I don't know why I said pound, that's a thing that Americans say. Okay. So now I do actually have to implement it. But now I can get a table index and an element index. Okay. The table-init instruction copies elements from a passive element segment into a table. Well, okay. So is this going to be, let's just imagine, is it going to be the same deal as this? Let's see. Table instructions is what I want. Size, grow, fill, copy. Init. DSN. Looks very much like it. So destination source length. Oh God, what are the APIs of these things? Let's look at initialize tables. Oh yeah, look, this is going to be relevant because this is sort of similar to what we did up here. Like, these are the active element segments. And now we want to pick out the right passive one, although I'm sure it doesn't need to be passive. So we've got destination source length. Well, I can get the element, can't I? So we'll slice out the right element. Oh, and also we can get the right table. Okay, well that, you know, that feels like progress. So we've got the table, we've got the element. It's only active ones have their own offset. Like we have an offset. So how do I want to do this? I think it's going to be this length times business. I think I'm just going to copy them one at a time. So I'm going to say table elements destination plus index equals element values. Oh, items. Right. Well, I could have seen that here, couldn't I? Is that okay? No, because that's a syntax error. Need the right kind of bracket. Undefined method elements for module. Oh, same deal again. So again, we need them to hang around at runtime. So up here in the definition of module, this reuse of the word elements is not particularly helpful. I think the table should probably just have values or items or something. Okay, so did we get any further? I don't know that we did. Well, like previously, we were trying to, yeah, see, we have got further. We were trying to invoke init, and it didn't work. Now we're trying to invoke call. Invoke init. Assert return, invoke call. But why didn't I get a... Why didn't I get a green dot for the invoke? Do I not get a green dot? I'm supposed to get a green dot. Oh, that's in assert return. So what happens if it's just an invoke? I think that should print out a green dot, because I earned that. Give me a green dot. Don't be stingy. Like, if it didn't blow up, I've earned I've earned a green dot, I reckon. I mean, this is gonna provide a lot of test inflation. But yeah, I mean, let's just do it before and after. So before it gets up to here, under the P of spec, now, oh, well, that's not a meaningful comparison, is it? This is what I should be comparing it to. Okay, so before gets up to the S of bulk.wast. After gets up to the T of bulk.wast. That green dot indicates that I've done something right. So let's do this. Print green dot when invoke succeeds, which just means execution hasn't blown up. But we deserve credit for that. Okay. So I think this is right. What problem is call having? I sort of want to understand the problem before I commit something which I don't know if it's right. So here we can say and here we can say so this is function index, isn't it? Okay, so let's at least, I haven't really read the code to see what it's supposed to be doing, but let's just get a feel for it. Calling in directly from table 0, table is blah. Elements is nested array with a func ref, nested array with a func ref. Doesn't seem very right, does it? Like, why is this a... And then a function is an array. Okay, I think probably something's going wrong. I've just I haven't thought about this properly. Before table is table inspect, element segment is element inspect, and then this is oops after. So let's see what happens for the execution of this. Before table is elements nil nil nil. Element segment is items. Yeah, like this element segment seems to be each item is an array. Ref func, ref func, ref func, ref func. So that's doesn't seem entirely right to me. But what's supposed to be happening? Like, what do we even want? Like, what's even going on with ref func here? Like, oh, these need to be evaluated. These haven't been evaluated. That's what's going on. This, yeah, we've just got raw AST nodes here. So when are these supposed to get evaluated? Is the idea that these get evaluated during module initialization? Instantiation? Okay. The execution semantics defines initial instantiation, which allocates instances for a module and its contained definitions, initializes tables and memories. So let's think about allocation. Well, functions, tables, memories, and globals. What happens element segments? Memory global. For each element segment elem, which contains this init vector of expressions, the element address resulting from allocating an element instance of reference type blah this doesn't really clarify. The vector of references to allocate. So, I mean, that really suggests that all of those expressions need to have been evaluated, because they're not references, they're constant expressions. Right, here we go. Let ref star be the list of reference vectors determined by the element segments in module. These may be calculated as follows. For each element segment elem in module module.elems, and for each element expression in elem.init, let ref be the result of evaluating the initializer expression. So really, we need to evaluate all of those element expressions during module instantiation. That's what this means. Okay, so I mean, is this at least do we believe that it's doing the right thing? So the table right now has got ref func 1, ref func 0, nil, and the function that's going to be called here is index 1. Is that right? So here we're supposed to invoke call with 0 and get 1 back. If we invoke call with 0, then it's going to call in direct the 0th thing. What's the 0th thing going to be? Init 0, 1, 2. Table init 0, 0, 1, 2. Okay, hold on. So table.init is destination, source, length. And it's talking about element index 0 because the table is implicitly 0. So it's talking about these two. 0, 1, 2. And that's actually what we pass in. So the locals here, 0, 1, 2, actually have the values 0, 1, and 2. So we call init with destination address is 0, source address is 1, and the length is 2. So we're going to ignore this one. We're going to pick up these two, the functions 1 and 2. Sorry, the functions 1 and 0. And we're going to place them at index 0 in the table. So I'd expect to see the function 1 at the first position in the table, the function 0 at the second position in the table, and for the third one to be nil. Yes, and that is what we have. I know I just read that out before, but I'd already forgotten it. And we're expecting to call the function 1 that returns a 1, and that is what is going to happen. I'm just trying to decide whether to hack this, because I could evaluate the expressions right here. So like much later than they're supposed to be evaluated. Oh, that hasn't worked. Oh, that's because that's not how evaluate expression works. I keep forgetting that. So something like that. Yeah, so that does actually make the test pass. Okay, so I'm gonna, somewhat against my better judgment, I'm gonna commit that because it's a local change. It's just additive, right? And it's wrong because this evaluation is happening at the wrong time. But then there's a separate change to move it earlier during module instantiation. And let me make a high priority. Evaluate all element expressions during module instantiation, not during table.init. Well, let's say passive element segment. I mean, we already are evaluating the active ones, but like for a different reason. So we need to have a runtime representation that stores the result of evaluating them rather than the expression itself. So this will be continuing our gradual march towards replacing, because at the moment we're still representing the element segments with their AST, but that is not right. Like, they need to be evaluated. So hold on, what have I done here? So this is add what did I say here? Store data segments on runtime module representation. I mean, really, this whole thing is useful, isn't it? So this is store element segments on runtime. Only active element segments are needed at module instantiation time. We need the passive element segments on runtime because the table.init instruction can copy values out of a passive element segment into memory. I think this is exactly the same situation again. Oops, I need that. So I think this is just gonna, this is just gonna be an ersatz retread of the previous thing. So the wording of the specification, the instruction copies table.init instruction, copies elements from a passive element segment into a table. Makes it sound as though table.init only works with passive element segments, but the WebAssembly test suite makes it clear that active element segments can be used too. And for that, we need to look at a different line of this. It's going to be this one. Store element segments. Active element segments are needed at module instantiation time. We need the passive element segments at runtime because the table instruction can be values out of a passive element segment into memory. The wording of the specification, element segment into. Okay, yes, that's all correct. We're being extremely naughty here by evaluating the element expressions at runtime. The spec is clear that element expressions should all be evaluated at module instantiation time. So while this makes the table init test parse, we should change the runtime representation of element segments to consist of pre-evaluated values, not AST expressions. Well, to contain. Okay, so it's not super urgent that I do this straight away, but as I said, we are being extremely naughty by doing it this way. But I think I'm basically what it comes down to is I'm getting tired, and I would rather get to the end of this file and have the test pass than go off on a tangent and change the runtime representation of element segments. elem.drop. I think it's going to be very similar to this. Just going to set it to nil, and then we're probably going to need some nil tolerance. That's interesting. We didn't need any nil tolerance. Oh, I suppose because this is doing length.times. So actually, whereas, and maybe that's interesting to say. The implementation, I don't know why I started typing whereas, that was a stupid thing to type. The implementation of data.drop, the virtually identical implementation of data.drop required a change to the implementation of memory.init to prevent it from trying to access the dropped data segment in the case where the length was 0. We don't need to make the same change here to the implementation of table.drop, table.init, because that implementation already uses, what is it, length.times do, which well, let's say that implementation uses blah, which already does nothing in the 0 length case. Okay, cool. Well, that's a nice example of somewhere where I was expecting to have to do something and actually I didn't have to do anything at all. Okay, I feel like the end must be in sight here. Table.copy, I mean, it's literally the last thing. So let's do this. I think table.copy is another one of these annoying table instructions. That's got the abbreviation that I don't like. Yeah. Oh, Oh, this is different actually. That's weird. Let's just see what this looks like. Oh, well, let me just, I just want like a field sample of these. So here, both are provided. There, neither is provided. Both. Well, it definitely looks like this is correct. I mean, yeah, I mean, I assume one of these is the source and one is the destination table, but the abbreviation is just that you can, if you don't specify, you can omit both, and that means I'm copying from and to the first table. Okay, well that's weird, but okay. Even though I don't need to, I'm just going to get this out of the way. So let's say if peak in index regexp, then I'm just going to assume this is source table index equals parse index. Ridiculously long. Destination table index, else. Well, we can do this, can't we? Why didn't I feel like it was appropriate to do that up here? I think it's because this expression was so large. In this case, I feel sort of relaxed about. Just doing that. Else. They're both zeros. I think these can be. Again, we don't need the table. Because they're implicitly tables. It was because I was looking at this, but here we need to, what varies is the kind of index, whereas here what varies is just they're both table indexes, so we don't need to specify. So yeah, if we can read an index, then we do read two of them. Otherwise, that's end. So this needs to be source index, destination index, and then here in table copy, I mean, I assume it's going to be like this. Memory copy was, oh, the destination is first. Okay, hold on. Let's make sure I'm getting these the right way around. Oh, X is the destination because we're pushing this table.get Y, table.set X. So X is the destination table. So this is all wrong. Well, not really, but let's get it the right way around. Destination source. Destination source. Capital F, see? Destination source. Okay. So destination table is current module tables slice destination index. Okay, so we've done the destination and the source. Length times do index table. Do we need to worry about these being overlapping regions in the same table? Oh god, yeah, we do. Oh, okay. Let's do this again then. So values, length times map do. And then values each with index. Okay, so this is going to say source table elements. Oh, see, I could actually slice. Okay, let me get this working, and then I think I can improve it, because you can slice multiple elements, right? Source table element slice source plus index. And then this is destination table dot elements destination plus index equals value. Yes. Okay, but now let's see if we can how do you set how do you like splice into an array? I can't remember. So you can, right, you can just provide a range. Well, that's getting. What about setting? I really can't remember how this works. Assigning. I mean, is it possible that assignment Yeah, okay. Oh. Yeah, okay. So it does what I want it to do. And I think I've probably said this already. It's so rare that I mutate stuff in Ruby that I just can't remember what is supported here. But that's great, because I think that means I can just write this as a single expression. Well, let's take it a step at a time. I think this can just be source table dot elements dot slice source plus in source length. Is that right? Well, it works. You know, the tests are passing. So that's something. So I should be able to do the same thing here. Destination table, elements, destination, length, equals values. Great. And now we can cut out the middleman. Phew. Easy. Okay, so first, store destination and source indices when parsing. I know this. Table.copy. Let's just say either both indices are present or both are missing. In the latter case, we assume 0 for both. Maybe let's use the word 0. Good old ID1, best part of that page in my opinion. Implement the table.copy instruction. As with memory.copy, these ranges may overlap. But we're copying all the elements from the source before storing them in the destination, so that's not a problem. And I think I also need to do this. So that actually turned out to be a bit epic, because there was a lot of stuff in bulk. But we got it all. So parser problem, yeah, and the rest. So I think the thing to do will be to next time have a look at all of these table tests. Because I think, I mean, at least some of them should already be parsing. I mean, shall I nibble away at those now? I'm just going to run them all. If any of them are already parsing, then let's just get it over with. Okay, so that's already parsing. That's already parsing. I mean, I don't think all of these are going to pass because I haven't implemented all of these. Yeah, table.fill needs table.fill, fairly obviously. Table.get. Oh, like needs optional index. That's what that looks like because it's trying to parse the index when it's not there. Yeah. Needs table.grow. Parsing. Wow. Well, this is better than I hoped for. Needs optional index. And have I implemented table size? Doesn't seem likely. Yeah. Okay, but I can add. Yeah. Table sub. Table copy. Table init. Init. Sub. Copy. Init. Let me just rerun the tests. Oh, what is wrong with me? Forgot to amend again. I always do that. That's my number one. That is my biggest of many weaknesses. That is my largest, which is that I keep forgetting to amend the previous commit with the test that it has just made parse. Oh, it's okay for me to stash this. Yes. Okay. Okay, so all of those ones that I've added are okay. Let's just very, very, very briefly, because this might be incredibly simple. Let's see if that is true for the parser. Table get. See, it's being handled. Get and set are being handled here. But I think, let's just see what would happen if I handled these separately. So in table.get or table.set, we'd remove those. We would say, well, we know the index space. We'd have this situation. Let's just see. Yeah, so they both just have a single index that can be 0. So let's say index equals if peak in index regexp, then parse index context.tables, else 0. And then that will allow them to be optional and to default to 0. If it's that simple, then great. Key not found. What did I do wrong? Oh, this has to go into opcode. Yes. Damn. Ref is null. Okay, well, what about table.set? That also needs ref is null. And table-sub.wast, table.copy.wast, and table-init.wast. Well, okay. And table-sub.wast. Sorry, I already typed this. Table-copy and table-init to parsing tests. I don't know how recently these started parsing, but I have just implemented a few table instructions. So it could have been recently. I'm not even gonna entertain the possibility that I need to find out when that happened. It's just not interesting. So this is something like support optional table index for table.get and table.set. It defaults to 0 if it's not provided. Okay. Actually have not been doing trailing commas in these hashes, so for better or worse, I'm going to be consistent. Well, it's better to be consistent. It's not necessarily better to not have the dangling comma there, but apparently that's what I'm doing. Can I be bothered? Ref is null. Let's do it. Is it reference instructions? Ref is null. So this is just making a decision. It doesn't take any arguments. Oh, it's underscore null. Okay, hopeful. Well, is null func ref. So we're calling it with 1 and 2. It's doing table.get. Oh, I don't know what this is doing. Oh, I think it's just checking for uninitialized slots in the table. So maybe this is okay. I'm sort of nervous that ref null doesn't actually do anything. But let's see what happens. Interpreter. Oh, ref null does push nil on. Okay, yeah, I was looking in the parser. I should have been looking in the interpreter, obviously, to find out what things do. How do booleans work? It's just whether it's 0 or not, right? Well, let's actually look at what the semantics are, and I'll just do that. If it's null, then push 1, otherwise push 0. Okay, that's good enough for me. Stack.pop, 1, value. Stack.push, value, nil. If it's null, then 1, else 0. Hey! Hey! Nice! That's all it took. Wow, that's very satisfying. Okay. Okay, well, I think this whole thing implements the ref is null instruction. That's very simple. Yeah, I mean, I'm a bit worried about using nil to represent null references, but that's what we're currently doing. So importantly, that means that I can add table.get, table-set, done. And then we've just got those three fairly simple instructions to implement, which I think I'll save for next time. Yeah, I think I will, because that's a nice easy win to get at the beginning. Do myself a favor. These only needed ref.is null. All right, let's run all the tests locally, and then I'll push them up to GitHub, and then I'm done. That was pretty good. How do I copy this char? I thought there was a button I could press that would let me copy the char. Obviously not in this view. So just letting this succeed before I type get push. There we go. There's all that table business. All right. So I just want to look at how many tests we've got passing. So in this session, we did call indirect, table, bulk. That was the really laborious one. And then we got table sub, table copy, and table init for what felt like free, but they might have been made to pass by work we'd already done. And then table get and table set at the end as a treat. That's 8. I count 8. Very exciting. All right. And what will be even more exciting is if the build passes, because then I can walk away. So I ultimately didn't get a chance to look at the parser and the abbreviation situation, but I think maybe I can do that next time, because this was a really good bite out of all things mutable. So tables and memories and elements and datas. I feel like I've been well covered today, and I can polish off these last few bits. Yes, it's passed. I can polish off the last few bits next time, just as like a warm up, and then I feel like it's defensible to then get stuck into yeah, thinking about abbreviations, because that's gonna have a sort of a ripple through effect in terms of it will simplify a lot of the stuff in the parser, even if I can do it incrementally. If I can incrementally move abbreviation processing into some kind of preprocessor, that will remove complexity from the parser and remove complexity from the interpreter. And then once I've got the machinery in place, it can just be a sort of an incremental thing that I'm doing to sort of move more stuff into the preprocessor, and then throwing away anything complicated that's been caused by abbreviations inside the interpreter. So yeah, I feel good about that. That was good progress, good sesh. But I think it is now time for me to say bye and go to sleep. So as always, thanks a lot for watching this. I'm very grateful. Yeah, I mean, that's 32 of these. Somewhat meaningful, not really. But I'm really enjoying this now. That was really good. I feel like I actually made some progress, and I've understood some more of the semantics of WebAssembly, and like I actually got 8 test scripts parsing. So that was a good one. So thanks for watching this. I hope you also thought it was a good one. But yeah, I'll see you next time. Bye bye.